Hello, guys. Thank you for joining us today, the afternoon, the morning, wherever you are in the world. So, very quickly, if you can just put in a comment where you're tuning in from, just to understand where our audience are coming in from. But today we have a very good show for you. We are going to be talking with MongoDB champion Mustafa Kadioglu, and we're going to be talking about how Cisco uses vector search and hybrid search and caching for their AI application. And Mustafa is a lead scientist and machine learning engineer from Cisco. And we can bring over Mustafa.
Thank you so much, Richmond. I'm so happy with this.
Thanks for joining us, Mustafa. So, with no further ado, we're going to go straight into the presentation. But guys, as we're going through this topic of vector search, hybrid search, and caching, and how we can enable this functionality using MongoDB, feel free to put any questions in the comments. Myself and Mustafa, we address them as we're going through this lovely presentation. So let's get started.
Thank you, Richmond. Let me share my screen. Okay, today I'm gonna show you or present you how we leverage Mongo Atlas Vector Search in our different use cases, right? Like in the RAG models, in the classification models, where the data is so skewed that we don't have enough samples from the minority class. If you are familiar with these terms, like the majority class we have, minority class we have, and then it is not easy to train a classical machine learning model. Then we leverage Atlas Hybrid Search to get these inferences from the model. And then, I mean, the vector search is not new, but with the RAG implementation with the GenAI, there are a bunch of new use cases. For instance, in one of use cases, we have been training the FAQ model, frequently asked model, which is a predictive model. And then in the last 3 years, we curated question and answer pairs from the the questions which come from the customer, and then the data we have for the Webex space. And then it is integrated into the Webex chat assistant of Cisco. So I'm just gonna explain you how we leverage Atlas Vector Search in the Webex chat assistant of Cisco to handle the FAQs, frequently asked questions, without creating any kind of question and answer pairs. And then and these data are, by the way, dynamic data, not the static, constantly subject to get updated. How we created a caching mechanism of this RAG by leveraging Mongo Atlas Vector database. And to keep this cache and updated, and then the vector database updated, we created a pipeline which runs in a daily basis, right? And then it's based on the requirement from the business. So if they say that, hey, you should run this cron job in a hourly basis, or every each 15 minutes, it's still okay. We can do that. But I'm just going to explain what's all this stuff and then how we created the pipeline end-to-end. So this is the agenda of the presentation. I'm just going to explain the definition challenges, the solution we came up with, requirements, technical architecture, keynotes, and the takeaways. And finally, I will show you a demo, a real-time demo. So how we get the inference, how we cache it. So next time, if the customer comes with similar questions, how the cache is, the data extracted from the cache, and how we keep the cache updated with the positive and negative feedbacks. So actually, the definition, I mean, you have mostly, I believe you heard about the RAG, retrieval augmented generation. This is the new technique which combines the search index, or searching a data from the indexed raw data, and then combination of the GenAI, generative AI, to get the final output from GenAI. Normally, in the past, we used to clean the data and then create some metadata from that cleaning data, and then index it in a database where we will be able to make the search, right? So mostly If we are talking about the NLP, which means that this is basically either MongoDB or Elastic, or there are some different use cases. If you want to go with the semantic search, then there are approximate nearest neighbor algorithms. You can use it offline or in public domain or public cloud environment. So RAG is also used to combine, as I said, the quality, improve the quality or relevance of generated responses, right? And then it needs the large data sets and then knowledge to index it in a vector database. And then additionally, you need to integrate it into integrate the GenAI to get the final output from the raw data. So there are a bunch of techniques like how we do load the data and then chunk the data and index it in a vector database. And then once we get the output from vector database, we then, based on input, how we are going to pass to GenAI with a prompt. These are all the techniques, but RAG has some like the drawbacks, right? So one of them is that the high latency. With the new GenAI, I agree with the new GenAI innovations. Right now, it is like we don't see that high latencies, but still latency is a concern. If your client also needs the output in less than a second, then RAG will not work. Then you need to cache it anyway. And the other thing is that the cost. So if constantly you hit the GenAI with a big volume of data, then the cost will increase up. And another issue is that this is also another challenge from the RAG. It is relatively hard to debug the model. Normally in the predictive model, you know what's the input and what's the output, and for that output, what's the prediction probability, and then you can easily interpret the model and then fix it. In the RAG, it's a bit difficult. As you know, the GenAI is a black box. You might also tweak with a small, a few parameters like the top K, temperature, top P, so on and so forth. But generally, it's a black box, right? And then if the output, the problem comes from the vector database or the semantic engine, the embeddings, you need to go back every step back to debug it. So these are the challenges. And our solution in the Webex chat assistant right now, as I said, the FAQ model is in production for more than 3 years. And then it, I think, deflected more than 120,000 cases till now, this chat assistant. It is not only the FAQ model, but we have different workflows as well. And then that, instead of, we are planning to replace the FAQ model with an RAG implementation, because in FAQ model, as you know, whenever the document is updated or modified, you need to also reflect this changes in your curated question and answer pairs. And then each time you need to analyze the questions from the customer, and then how, what's the frequency of these questions, how periodically these questions is asked, whether you address it in the current FAQ model. If it is not the case, you need to create a new question and answer pair, and then that question will need some additional variations, and then you should index it into the FAQ model training data, and then you need to retrain the model. So it needs a kind of recycle, and then lots of work behind the scene from the SMEs and then the engineers. But with the RAG implementation, whatever data you have as a source document, you need to properly chunk it, load it, chunk it, and then index it in a vector database. Whenever these documents are updated, you need to reflect these changes into the vector database if you don't have a cache. If you have a cache, you need to also reflect the changes in the cache environment. So in our use case, we have whenever the output comes from the RAG pipeline, then we also want the clients or customers to give positive or negative feedbacks of these answers. And these negative and positive feedbacks are closely monitored by the engineers, SMEs, right? And then, for instance, if you get a negative feedback, it goes to an SME, and SME also analyzes or assesses the input and gives either reject or it justifies the feedback from the customer, right? And then also the data changes, whatever change we had in the data, it should be reflected into the RAG and then the cache as needed. So the requirements is that we need a data auto ingestion pipeline. constantly ingest the data into the vector database and cache, right? And then we also need to keep the cache updated with the positive feedbacks. And then whenever we get a negative feedback or an output which comes from the cache, we need to clean this output if the engineers also justifies the negative feedback, right? And then we also need to make sure that whenever the data is modified, it's also reflected in cache. So our pipeline, we also filed an defensive publication, and it is approved and published in July 24. You can also go through this publication, Caching Retrieval Augmented Generation Model Trained with Dynamic Data and Dynamically Updating of Cache. So other than me, Paul Stajanovsky and Sunil Kartikota were the authors. Okay, so as you know, in a RAG implementation or any kind of AML implementation, we have the data ingestion pipeline and then the inference pipeline. In the current system, we have additionally the caching pipeline where the SMEs constantly and closely monitor the process. On the left-hand side, you see the indexing steps. So we do make two API calls. The first API call extracts all the metadata, all the source documents. So when the last time these documents are updated, and then the URL of these documents, content URL of these documents, like the HTTPS URLs where you can reach out through the web, right? And the persona, product, operating system, devices metadata we have. Whenever we get this metadata on the left-hand side, as you see, then the second thing is that get the content by making another API call. So once we get the content, we have a data controller that passes to the data loader. And data loader also loads the data. By the way, whatever you see here is end-to-end hard-coded by us. There is no, like the third-party automation orchestrators we use other than the vector database, MongoDB Vector Database. And then GenAI, as you know, we use the GPT, like OpenAI APIs. The rest, and then we have the RASA as an conversational AI framework. So the rest is hard-coded by us, like the data loader, because I will also explain the reason why. So normally with the new data loaders, you see that, hey, hyperlinks also are taken into account or not. In our use case, our clients also wanted us to show the hyperlinks in the answer as well. So we need to incorporate the hyperlinks in the answer, which comes from the source documents. That is the reason why we completely customized or configured the data loading, the data splitting and chunking strategy. Okay. So, and then whenever we convert the HTML text to the normal text, then we split and chunk, and then pass to embeddings API and index it into MongoDB Vector Database with the metadata. In that metadata, like, you know, like the current industry uses also like the semantic chunking, parent and child approach. In our use case, every chunk, every paragraph contains 8 sentences. So from after convert to text, we split the text into the sentences in a way that the hyperlinks will be intact. Like we are not going to cut the hyperlink in the middle. So we created a kind of logic to do that. So every 8 sentences become 1 paragraph, and then during the indexing, we keep the paragraph's index position. So this is the first paragraph, second paragraph, or last paragraph, or how many paragraphs we have and how many paragraphs we have in that document. So we index it into the vector database, then the inference starts. So I'm just going to go to the details for every step and how we do apply the caching. I explained this slide. So as I said, the chunking and splitting is unique for us. And then whenever we index the document in a vector database, MongoDB Vector Database, we let the SMEs know in the Webex space. Webex space is our like the communication tool. So, and in a daily basis, we run this cron job. In that cron job, we also check the deleted documents or updated documents or recently created articles or documents, and then reflect the the changing in a vector database, in a cache vector database, and then we also let the engineers know that, hey, if you see on the left low corner, we also let them know that, hey, these articles are updated, and then it is reflected into the vector database. So this is the inference phase. So customer comes with an either UI or Webex application, and then we have the virtual chat assistant here. So it identifies whether the input is related to the guided workflow or an FAQ. If says that it passes to the Rasa identifies it, and then if it is FAQ, the first thing we do is that we hit the cache vector database. So it gets to the cache vector database just after the converting to the like the vector representation, PI masking, these stuff. And then we came up with an weighted average semantic score. It is basically question which comes from the customer versus the index questions semantic similarity score, and then question and an answer in the cache vector database semantic score, and we put a weight both of them. If it is above the threshold, we directly pass the output, the answer from the cache vector database. If it is not the case, we directly hit the classical rec pipeline. So hit the vector database, Mongo Atlas vector database, and output consolidation. As I said, we have the index and then the total index. We just go one previous index, one after index to combine them. And with a dynamic prompt, we pass to the context to GenAI to get the output. So here, as I said, there are a bunch of like the metadata we do use. For instance, user, what's the role of the user, right? Either it's a user, administrator, or our partner, or what kind of product user uses, what kind of operating system in his PC or the like device, right? And then based on these input, which comes from the KYC or from the question as well. So we have the entity extractor as well. We know that user specifically looking for this product, operating system, or the device. So if the output comes from cache, right? So basically customer comes with a question, and then Rasa identifies that this is FAQ. Then we have the PI masking here, embeddings here, and then we hit the cache vector database. And as you see, we have the weighted average semantic score, which is 0.7 times query versus the question in the vector database, and query, which comes from the customer, versus raw answer in the cache vector database. If it is score, the average weighted score is above a certain level of threshold, we do pass the output from cache vector database. Otherwise, we do trigger the rec pipeline. So the answer comes from the GenAI. I'm just gonna like switching from the answer, two different answers. We have the answer from either rec pipeline or the cache vector database. What happens? We get a positive feedback from the customer. So let's say in this example, right, we have an answer which comes from the rec pipeline. We didn't hit the cache. Cache didn't generate that threshold, right, the semantic threshold. And then the customer gives a positive feedback. Then in the backend, what we do is that the question customer asked is hit the GenAI to create multiple variations. And then we just map these variations with the answer where we get the positive feedback. And then we hit both question and then the answers to the embeddings API to convert these text to numerical representation. By the way, the main question becomes the primary, and then the variations, which is generated by the GenAI, become secondary. And then with the same hash code, we create an hash code, which is unique 9-10 digit hash code. We index it in a cache vector database. So what we are trying to do is that, hey, whenever we get a positive feedback from a question, that question becomes primary. And then in order to improve the possibility to hit the cache vector database next time, we create n number of different variations of this main question with the same answer, with a unique hash code. We index it in a cache vector database. Meanwhile, the main question becomes primary, and the variations become secondary. Why it is important? Because next time, if the source documents of this answer, if one of them or some of them are modified, then we are not going to go through all these question and answer pairs in the cache vector database, but only focus on the primary one, to replicate the same environment to get the answer from GenAI, and then see whether GenAI also generates the same valid answer based on the new updated document. If it is the case, we will just reflect the answer across all the primary and secondaries under the same hash code. So, and then like this positive feedback is also sent to engineers to see, hey, we get a positive feedback, customer asks how do I join a Webex meeting from space list, and this is the answer. And we have what was the persona? It was administrator related, Webex meetings and webinars. Webex application was the application, and then these are the source documents. So we know that how many source documents we used to get this answer. So I'm just going to show you a schema from the cache vector database, right? So the main question is, I want to update my virtual background in a meeting. So customer came up with this question, and then we know that customer was an end user, not an administrator or the partner, and then he chose the Webex meetings and webinars as a product. So you see on the left-hand side on the cache vector database schema. So the main question is, I want to update my virtual background in a meeting, and we had only one document, and that one document has an external ID, as you see here. So we might have multiple. Sometimes we have 6, 7 documents where the GenAI also generates the answer. So we keep all these documents in a cache vector database. Okay, and then you see the scores, and then we get the positive feedback. And as you see, this is the unique hash code which identifies the question and a product and persona. And the main question which comes from the customer becomes primary, and the synthetically generated questions become secondary. So now customer asks another question, and then the answer also comes from the cache vector database, right? So we didn't hit the cache, we didn't hit the RAG pipeline. The answer also came from the cache vector database. As you see, customer also asked similar question. I need to change my virtual background in a meeting. So what was the first main question? I want to update my virtual background in a meeting, and we had three variations here, and one of them hit the semantic score, which is above the threshold, the weighted average semantic score, and the answer came to customer from cache. Customer gave a positive feedback. In this time, you see the question which gets from cache and customer gave a positive feedback became secondary under the same hash code. So this is the new question gets positive feedback as a secondary row, right? So next time, if the 80JDAUAB, the external ID document is updated, right? We know that it's updated, there is something changed in the document, and we know that I have 5 questions which is related to this external ID. So I need to make sure that the answer is valid. So I need to make sure whatever the answer I provide to customer should also get updated. So what I do is that I do replicate the same environment. So the persona is user, product, Webex meetings, and webinars. Here is the question, the main question, right? And then I get the answer from the RAG pipeline. So we have another pipeline which runs the RAG, and then the output comes in. That output was also sent to, so we have an evaluator, which I'm going to explain it a bit. So if the evaluator, based on the answer relevancy, the context relevancy, and the groundedness or faithfulness, if the answer passes that evaluation, we directly reflect not only the primary, but the secondaries, because we know the hash code. So based on this hash code, all the answers under this cache vector database are updated with the new answer. If it is not the case, it will go to the SMEs to validate. So SME will see that, hey, this is the question, this is the answer, And then these are the source documents. If the SME also says that, hey, it is good, then we will reflect it into the cache vector database. As you see, human in loop all the time. With the agentic framework, we can also integrate these agents, and then we can also let these agents also train with this logic. But in our use case, the data is so dense, and I mean, most of the time, we do need SME support to get the output. Okay, how about we get negative feedback, and then this negative feedback comes from cache? So the answer, the customer came up with a question, and then the Rasa identifies that this is FAQ, and then we hit the vector database, cache vector database, and then answer came from cache vector database. In this time, the customer gave a negative feedback. Then that negative feedback is kept in an interim database. And then at the same time, feedback orchestrator also sends this negative feedback to SME. So we are not directly clean the cache vector database, but we need an SME support because customer might frustrate not only the content, but like, hey, the answer is too long, or I don't want to read it, so I give a negative feedback. So these kind of things might also happen. And so we just want to avoid arbitrarily deleting the cache with the negative feedback. That's the reason why the SME is in place here. So SME either accepts the negative feedback or rejects. So in this example, it justifies the negative feedback which comes from the customer. So it says that, hey, this negative feedback is true. And then what happens, as I said, in the Webex space, SME also get notified with an Webex card, right? Notification. And here we get a negative feedback. So how to not let the others see my virtual background. So it might not make sense, but this is the query. And then we provided an answer. GenAI provided an answer. And then we got a negative feedback from the client. And then this negative feedback is also accepted, justified by the engineer. Hey, that client is true. So the question, the answer is not whatever the GenAI generated is not answer of the question. So if the engineer accepts it, what we do is that based on the threshold we discussed, right, the weighted average semantic threshold, we clean everything from cache unless that the threshold, whatever less than threshold, right, less than threshold, they will stay as it is, because next time if the customer comes, how to not to let the others see my virtual background, we are not going to show how can I change my virtual background during in a meeting related stuff, right? And then next time, similar content, we will hit the pipeline, not the cache vector database. And as you see, one of them also became primary, because if the primary question is also cleaned based on the weighted average semantic score, one of them, the high score, will become the primary. Because next time we will get positive feedback of this, how to change my virtual background during a meeting, positive feedback, and then the document is updated. Then we need to reflect this change, the modification in the cache vector database. That's the reason why we should keep one of the questions which has the high score under the threshold as a primary under the same hash code. So the answer, these are all different scenarios, right? The other answer is also, the other scenario is answer comes from cache vector database, but the feedback is rejected by the SME. So SME saw the answer and then rejected because it says that, hey, still this is the answer of the question. Customer had different frustrations or different disturbance. In this case, the answer, whenever the kept in MongoDB, the Mongo Atlas interim database, so it is deleted there, because whatever you see here, these are all kept in a reporting system. So when the session is created, open, so who was the customer, what was the question, how many minutes or seconds customer was in the session, what kind of questions is that, everything is kept in a different let's say database where we can see all these reportings, dashboards. So here, this is just only for the feedback purposes. So the SME also rejected that feedback, and then it is cleaned from the interim database. There is nothing happened in cache vector database, no action. So next time, similar question, we will provide the the same answer. So as you see, the customer came, how to change my background in a meeting. We got a negative feedback, and then the engineer also selected as discard, and then there is nothing happened. The cache vector database kept as it is. So what happens? A document is updated, right? So say we have a cache vector database, and then, whenever the document is updated, we directly delete the document chunks from vector database, and then reindex it, the new chunks of this document. We are not going to check whether which paragraph is updated. No, nothing. Just we have a one document, one source document. It is updated directly. We clean the vector database, not cache, but the vector database, and then the new chunks are indexed. And this is instant, like the clean and index, like in seconds we do that. Okay. So what happens in a cache vector database is that, so we know that this document is updated, and we know that maybe 20 different primaries needs to get imitated with the same environment, right? So we know what was the role of the end user, partner, or the administrator. What was the product? What was the operating system? And what was the question? The same pipeline is triggered, and here is the answer. So the answer comes from the rec pipeline, and then we trigger the evaluator based on the context relevancy and the answer relevancy, and then the faithfulness. It generates a score. I mean, these things, right? This is basically the splitting into the sentences and then compare every sentence, whether it has in the answer context, the question wise, the answer versus context, question versus answer, so on and so forth. So whenever we get these three outputs, right, we identify that, hey, the answer is good. Let's reflect the answer into the cache vector database, and then all the primaries and secondaries are updated with the new content. If it is not the case, it goes to the SME, and SME also sees the answer with the new question, and then the modified documents, and it says that, hey, this document, this new answer is good to go to reflect in a cache vector database. Cache vector database is updated. No, the answer is not good. All the answers, question and answer pairs under the same hash code, primaries and secondaries, these are all cleaned, entered. So next time we are going to go with the new question and answer pairs to keep the cache is updated. So normally, if your documents, right, the training data is static, then it is pretty easy to keep the cache updated, because whenever you get positive feedback, like you are good, you can keep it, no need to create a hash and everything, right? But in our use case, this is quite dynamic environment. The documents are constantly updated. Then we need a cache because we have an inference concern, right? Inference time concern. So that's the reason why we need to keep the cache vector database updated with whenever the answer is, like, the data is modified. So as you see, this is the defensive publication we filed and then get and approved. So keynotes and the takeaways. So if you need a production ready rack, you need to customize it more than classic predictive models. This is for sure. I mean, with the new vector databases, it's a huge, advantage for us, right? To spin up really easy in the backend, or you can go with the UI or with your code, right? Script. You can configure the vector search or the normal keyword search, right? So it's pretty easy to spin up. Indexing the data is pretty easy. Debugging of the vector database is quite easy, because you know that whenever you come on an input, what's the relevancy score in the semantic and lexical. So whether the data is properly, let's say, labeled, right? Just let me give you an example. You have a classification problem, like a classification model, and then each time you think that, hey, what's the issue with the model, right? Why we get like 0.25, like less confidence score. Then there are some NLP libraries you can leverage, right? Maybe you can go with the keywords, highlighted keywords, right? Sharp line type of models, like the frameworks you can leverage to figure out. But at the same time, you can also index it in a cache, the vector database, and then you can make semantic and lexical calls as well, right? To see whether semantically the mispredicted input is semantically relevant with another one, or syntactically relevant with another, let's say, action or class, right? This kind of debugging you can also do with cache vector, the vector databases. This is another thing. So in our use case for the racks, yeah, we for sure we go with the vector databases. But as I said, with the classification problems, the data is quite skewed. We still go with the vector databases with hybrid search. In our use case, hybrid search meaning that semantic and then the syntactic. And for syntactic, like we use the weighted RRF, and then we have been working on another thing. Like in weighted RRF, you see, hey, you can also put, like for the semantic, you put that like weight, and then the syntactic, you put another weight as well to re-rank the outputs from the semantic and syntactic. We have been working on in a logic to dynamically identify these weights. For every each query, what will be the weight of the semantic and then the lexical, which comes from the probability of the document in the indexed, like the training data. So these kind of techniques we do try to apply to get the best output from the vector databases. So now I'm gonna switch to the demo. This is our UI. So as you see, this is a Webex chat assistant. It is not just only the FAQ model, and then we have like different guided workflows, like close to 35 guided workflows. So one of them is FAQ, and then that FAQ is right now is, as you see, this is we have an FAQ model in production, which is curated input. Right now, we are gonna replace the FAQ model with the output from the RAG. So this is for the like the debugging purposes for the engineers. So as you see, we have the demo mode false and demo mode true, meaning that so if the engineer wants to see what's the output end to end from the RAG pipeline, he goes with this UI. If it is just only for the end user who will test the model, then we have different things where the customer will not see what's going on in the in each step of the RAG pipeline. So as you see, we have different parameters like the customer, user, like the end user, user administrator or partner, product, application, device, or operating system. So if we select one of them, right, I'm just going to give you an example. So I just hit how to join a meeting from how to join a Webex meeting. So these answers, whatever answer you see, comes from the FAQ model. And this is the answer which comes from the cache vector database. Okay. So basically, so different, we have the, let's say, devices, so on and so forth. It's properly, let's say, articulated. As you see, we have the hyperlinks are also incorporated. What's the source documents? We see 3 source documents here. You can easily go and check what's these source documents and how we extracted the proper article or proper content from here. And then what was the prompt in the back end, and then the computation time. So these are the things where we do provide to engineers or the SMEs who will debug, who wants to debug the model end to end. If it is more complex than anything, then we do go back to the back end. I'm just going to show you the back end, right? So since it came from the cache vector database, so as you see the input, how to join a Webex meeting, user, persona, product. So we have the PIMS query, different calculations here, embeddings API we hit, and then we get the scores, as you see, and then the variation status from cache vector database primary, and then the output also came from cache vector database. So from the how to join a Webex meeting, we hit the primary question with these different scores, and then the highest one also came on top from the cache vector database. So what I'm going to do, I will go with the different, let's say, persona, and then I'm just going to ask the same question. So it will take some time, because in the backend, what's going on? Like, we go back to the okay, a bit more. There are a bunch of stuff going on in the backend. You'll see. So how to join a Webex meeting, and the persona administrator, and then there is a Webex meetings and webinars are the product, and then no application devices operating system. So you see the embeddings API, and then this is the persona, Webex meetings, bunch of stuff going on, and then the vector database, there is no answer from cache vector database. RAG pipeline is triggered for the query, and in the RAG pipeline, we get the whole list of documents here, and then after like the refinement, we get the list of documents here, and then finally the final list of documents in the backend. So, and here the prompt, right? And then in that prompt we have, this is dynamic prompt, by the way, and then the context also, we pass the context end to end to RAG pipeline, right? And then the answer also came into the UI. So this is the answer. So, and you see we have the source documents, we have 6 source documents, and the prompt was huge. And then we have the computation time as well. It took 12 seconds to get the output. So if I say I found what I need, what's happening in the backend. So you see we have a positive feedback. It didn't run right now. So let me run it again. So I'm going to go with the Webex meetings and submit to join Webex.
Wow, Mustafa is re-entering the prompt. We have a link that can teach you and show you how to implement semantic hash, similar to what Mustafa has implemented. I'm going to provide a link in the chat section in a minute. But this is really good, Mustafa. I've got loads of questions to ask. I need to finish, but yeah, I'll let you finish off, then we can get to the questions.
Okay, so if I run this one, I think there is something wrong here. So this is demo purposes, but anyway, so the positive feedback, as you see, we just reflect in the Webex space, and then for the negative feedback, again, we have either accept or discard buttons here for any kind of negative feedback. So the engineer chooses either accept or discard. If it is discard, meaning that we are not going to reflect the cache vector database, anything like cache vector database we kept as it is. If we select the accept, whatever the weighted average score above the threshold to generate this answer, these are all clean from cache vector database, and then we will keep the cache vector database intact. So, and this is a cache vector database. We have a bunch of, by the way, here attributes in a cache vector database, but I'm just going to show you, right? So here is the hash code. And for instance, we have a question, which it was, let me get this one. So this is the primary under the same hash code. So how do I share a link to Paul in Slido? This was the main question, and user and Webex meeting. And here, these are the synthetically generated by GenAI. What's the process for sharing a Slido poll link? And this is another one. Could you guide me how to send a link to Slido poll? And I'm struggling to share a link to Slido poll. As you see, under the same hash code, and these are secondary rows. right, with the same source documents. These are the documents external IDs. Next time, as I said, if one of these documents are updated, right, then we are gonna replicate the same thing. This is the user, this is the product, and this is the main question: how to share a link. All in pseudo, and the answer comes in from the GenAI, and we do apply 3 techniques, like 3 evaluations. If it does not pass, it goes to the cache vector database LLM space for the engineers to go and evaluate the answer, assess the answer. So if the answer is correct with the new updated document, it accepts, and whatever you see here in the hybrid, like the hash code, primary and then the secondaries, all their answers are got updated with the new new answer. This is basically start sharing the.
That was very good. I have so many questions, and I learned a lot of things from you, Mustafa, just especially on how you are keeping human in the loop in different steps of the process. This is well thought out. I have a question going back to the start of your pipeline. You said you're using just 8. Your chunking strategy is to just chunk 8 lines of all the text. So you're using a fixed chunking strategy. And the reason was you didn't want the hyperlinks to get cut off. Did you try any other chunking strategy before you settled on the fixed method?
So basically, the logic is here that to parse the text, whenever you convert HTML to text format, right? We need to parse the text in a way that the sentence will be intact, meaning that the structure of the sentence is kept, including the hyperlinks. So, and then like we went with the part, like the parent-child technique. We went with the constant or fixed character length approach. But at the end of the story, like this approach came to us like the output, right? The empirical output was better. And one thing, so let's say we have one chunk, and then we just label this chunk is index position, and this is the first chunk in my text, and how many chunks I have is 12. We keep these numbers in that dictionary while passing it to the vector database. If the vector database spits out based on a query, we know that this is chunk number 2, and I go chunk number 1 and 3 and concatenate them. So it is not just like, hey, one chunk and pass to GenAI. So we just go one previous and one after chunk and concatenate them. And if we have overlap chunks as well, we just delete them to create one big paragraph. So this is not just a simple like converting to the sentences and go with one chunk, and no, just after we get the chunks from the vector database, we just go neighboring chunks and concatenate them under one, let's say, document, then pass to GenAI.
Yeah, that's an extension of the fixed chunking strategy, and that's a very, very smart approach. You mentioned a bunch of evaluation metrics, answer relevance and faithfulness. What library or framework are you using to evaluate this system?
So we use RAG as a service, RAG-S evaluation.
Okay.
Right, but like basically, I mean, as you see, right, this is end-to-end. We hard-coded the RAG. You can also hard-code your own evaluation technique. This is like, for instance, in this case, we split the answer into the sentences and compare whether it's in the context or it's in the like in the answer. The question is in the answer, so on and so forth. You can come up with different techniques as well, right? Hey, so, and then whether we have the keywords is in the answer, not only like a whole bunch of sentences, but keywords in the answer, so on and so forth. I mean, right now, as I said, if you go with the like the question, answer, source document, and then the golden answer, right? Then you might also increase this evaluation techniques from 3 to 8, right? The precision, recall, all this stuff, right? So right now we use RAG-S as a framework.
there are some techniques that I saw you doing that are very interesting, which was when you're caching, it's generating different questions from the query, from the original query, different variations. How
Yeah.
did you guys come up with that? Was that from testing, or did you read it somewhere, or was it just a
No,
creative?
it's for like I mean, AI meaning that problem solving, right? So we just tested out that like, hey, sometimes it didn't hit the proper answer, like proper question answer from cache vector database, but even the question is relevant, right? So because this is basically sentence transformers we do use, and then you need to fine tune or train from scratch your sentence transformers. Anyway, like they will put some weight on it, and this is not lexical search. Like there is only semantic search in the cache vector database. So what we thought that hey, why not create a number of different variations? It's up to you. And in GenAI, sometimes whenever you exceed a specific number, then this is only the stop words makes sense, but like the actual words keep in like almost the same. If you go with 10, 20, then the stop words will get changed. Otherwise, the words, actual words, will be the same. So we ended up with 3, but it is, by the way, configurable. So let's say if my customer wants to go with 10 sentences, right? It can go with the 10 sentences as well.
Yeah. I have another question, and this is probably the one that I was wondering the most is, why did you decide not to use any abstraction framework like LangChain, Llama Index, Haystack? I'm guessing you decided not to use it because you said you hard coded the RAG pipeline. What influenced that decision? And yeah, I would like to understand why.
No, I mean, basically, we tried LangChain and Llama Index in the past, right? So, and then the main problem was that we want to control every each step of this track. So, for instance, how the data is loaded. So, for instance, like some articles has tabs, right? So these tabs, and then under these tabs, this is HTML in the Webex space. So in web space, there are some different contents. So if you go with the basic LangChain or Llama Index, they do not address these kind of like the content extraction properly with the headline of these tabs. So, and then our clients also said that, hey, what I want is that there will be a consecutive labeling, right? The ordering. Here is the tab headline, and then the tab content, tab headline, and the tab content, tab headline, and the tab content. Now, you cannot go with the like LangChain or Llama Index, like the third-party orchestration tools to do that, right? You need to switch from from these kind of libraries to hard code. So, and then we said that, hey, let's go with a hard code. And again, for instance, the index positions with the paragraph index position indexing, right? You need to put a layer between the LangChain data splitting and chunking and then indexing in a vector database. So, and then getting the output from vector database to make some additional consolidation steps, right? And then we just figure out that, hey, let's make it end-to-end hard-coded. Let's see what's going to happen, right? And
so it was a progressive change. First, we used it, we learned, and then we started to take it apart and just go full code solution. I have another question. I was thinking, I have loads of questions. How have you used prompt engineering within this system? I'm sure you're using prompt engineering to basically extract the different variation of questions. Is there any other places you're using prompt engineering?
Like right now, if you are talking about the fused RAG, meaning that whenever the question comes in, you multiply, create some generic questions, and then hit the vector database, so on and so forth. No, we do not use the fused RAG. The reason why, still the latency is our main concern. Even it goes to the RAG pipeline, right? So latency will increase up if we get additional, let's say, variations from GenAI during the vector database hit. Our prompt is dynamic, like meaning that we have an instructions, right? So you keep the GenAI, like do not hallucinate, right? Whatever the answer comes, it should be in the context. And then one other thing is that this is pretty good color. whatever the input comes in, the answer should be in English. Why? Otherwise, we need to put an like translator, right, between the customer and then the pipeline, because RAG, whatever the output comes from the cache, the GenAI, the RAG pipeline, we index it into vector database, and there is no lexical search. Just think about, right? If the customer says that I just want to get the answer in German, right, then next time semantically it will be similar with the answer which is English, and then we will provide the German output. So these kind of let's say instructions we pass in the prompt, and then the context, right? And then we say that like focus on some specific applications, some specific operating systems, so on and so forth, which comes from the query entity extraction or the KYC.
That's very good. And that would be my last question. But for anyone that is listening, if they want to contact you to ask any more questions about this, how can they reach you?
Like they can reach me through the LinkedIn. And then I'm getting pretty good like feedback from LinkedIn, right? So and then like I do try to reply them back as much as I can. But I mean, I show you the caching, let's say defensive publication as well. There is a huge good information over there. This was just only a summary, so you can see every step how we articulated all this process, right, end to end. And like I mean, if your data is dynamic, if your clients also need like more than what the LangChain or the Llama index provide you, right, then you need to configure it in a way. So there is no answer that, hey, I cannot do that. So LangChain or Llama index has not came up with this solution, but you should switch gears and then, hey, can I do it by myself, so on and so forth. So you can also combine both of them, right? But the good thing is that vector database over there, and then the hybrid search is there. Like the caching is, as I said, based on your requirements, you can cache it as well. Like if your data is dynamic, different logic. And for this one, right, we have only one data sources. So there are different use cases where we need to also apply a kind of ETL before splitting the data. So like the case data we have, right, the ticket data, and that the ticket data we have 8-9 different node types. The emails, like the customer symptoms, phone logs, like the Webex messages, right? You need to extract these data in a way that you will clean and then index it in a vector database to get the relevant content from cache, from the historical data. So as I said, like there is not one solution you should apply for all your use cases.
So thanks a lot for your time and taking us through this in-depth solution to a very unique problem. And I'm very impressed with the amount of human in the loop processes you have for thumbs up and thumbs down, and accepting and rejecting some of the negative and positive feedback. That is quite unique and useful, and that's a very key big takeaway from me. What we're going to do is in the description, in the show notes, we're going to leave Mustafa's LinkedIn, a link to the paper, and a bunch of resources to help you, the listeners, the watchers, build similar systems such as this, and at least have some of the knowledge that Mustafa has shared with us today. So that's all we have for today, folks. So thank you for joining us. And I want to give a special thanks to Mustafa. And I have one special request, Mustafa. When you start building AI agents and turning this into an agentic system, could you come on the show again and share it with us?
Sure. Thank you so much, Richmond, for having me. And thank you so much for the audience who show patience to listen to me. I'm happy to help. Please just reach me out, and then I will share whatever I have in my knowledge, experience, based on my experience. Yeah, let's continue to share. Sharing is caring.
I love it. Sharing is caring, and that's a good way to end the show. Thanks a lot for your time, guys, and see you next time.
See you. Bye.